IBAIS October 2023. Time Zone 1, Paper 2. Question 1. The diagram shows a cross-section of an object. The shaded part represents the area between the curve and the x-axis, and the function of the curve is given in the question. We are given some data for x and y, and we want to find the values of a, b, and c. To do this, we simply substitute the given x values into the function to find the corresponding y values. So a is found by substituting x equals 16, b by substituting x equals 32, and c by substituting x equals 48. Next, we use the trapezoidal rule to estimate the shaded area. We take half of the sum of the boundary y values, add all the middle y values, and then multiply by the interval width, which is 16. Part C. We write down the integral to find the exact area. That is the integral of the curve equation from 0 to 64 with respect to x. Using the calculator, the exact area is 405.3, correct to 1 decimal place. Finally, we calculate the percentage error of the estimation. That is the absolute value of the difference between the estimated and the actual area, divided by the actual area, and then multiplied by 100%. Question 2. We have a diagram where AB is 90 meters long. M is the midpoint of A and B, and we want to find the length of BM. That is simply half of 90. So BM is 45 meters. ME is 32 meters long and is perpendicular to AB. We want to find the length of BE. Pythagoras theorem on triangle BEM, we get BE equals 55.22 meters. Next, we want to find angle BEM. Using tangent on the same triangle, we get 54.58 degrees. Part C, we need to find the arc length AB. Since E is the center of the circle forming arc AB, we can find the circumference of the entire circle with radius 55.22 and then multiply it by the ratio of the angle to 360 degrees. Part D. There is an outer edge CD, which is also an arc with the same center E. The width of the track is 4 meters. We want to find the area of the track region ABDC. That is just the difference between the two circular sectors. The outer one, sector CDE with radius 59.22, minus the inner one, sector ABE with radius 55.22. After calculation, the area is 436.1 square meters. Part E. The base of the track is made of concrete with a depth of 15 centimeters. To find the volume of the concrete, we multiply the base area 436.1 by 0.15 meters, giving 65.4 cubic meters. Question 3. We are given a grouped frequency table for the running times of 200 movies. To find the mid-interval values of t between 70 and 80, we take the average of 70 and 80, which is 75. To estimate the mean running time for the 200 movies, we find the mid-interval value for each group, multiply each by its frequency, add all the results together, and then divide by the total frequency, which is 200. After calculation, the estimated mean is 88.15. Next, we are given a cumulative frequency graph. To find the interquartile range, we locate the lower quartile and the upper quartile on the graph. The lower quartile corresponds to cumulative frequency of 50, which gives a running time of 84. The upper quartile corresponds to a cumulative frequency of 150, which gives a running time of 91.5. Taking the difference, the interquartile range is 7.5. Part C. We need to check if a running time of 100 is an outlier. The upper boundary for detecting outliers is the upper quartile plus 1.5 times the interquartile range. That is 91.5 plus 1.5 times 7.5, which equals 102.75. Since 100 is more than this is not an outlier. Part D. We perform a chi-square goodness of fit test to check if a sample of 200 movies follows a normal distribution with mean 88 and SD 6.75. We first write down the hypothesis. The new hypothesis, the running times of movie can be modeled by this normal distribution. The alternative hypothesis, the running times cannot be modeled by this normal distribution. We are given a table of observed and expected frequency. We need to find the missing values A and B. Let T represent the running time, which follows the normal distribution given. A is the opportunity that T is between 85 and 90 multiplied by 200. B is the probability that T is between 90 and 95 multiplied by 200. We find both probabilities using the calculator. Finally, with a 5% significance level, we calculate the chi-squared test statistic and the corresponding p-value. The degree of freedom are number of columns minus 1 times number of rows minus 1, which is 4 times 1 equal to 4. After entering all values into the calculator, we get a p-value 0.0166, which is more than 0.05. Therefore, we reject the new hypothesis. Question 4. A man buys a car for 285,000 ZAR. He needs to take a loan and makes an initial down payment of 25% of the price of the car. The loan period is 5 years with a nominal interest rate of 4.5% per year, compound monthly. He will make equal monthly payment at the end of each month. Part A. We first find the amount of loan after the down payment. That is the price of the car times 1 minus 25%, which gives 213,750. Next, we find the monthly payment correct to 2 decimal places. We input the following into the financial calculator. N equals 60, I 4.5, PV 213750, FV 0, PY 12 and CY 12. The monthly payment PMT is 3984.95. Part B. We want to find the total amount he will pay over the life of the loan, excluding the initial down payment. Since the loan lasts 5 years, that is 60 months, so multiplying the monthly payment 3984.95 by 60, giving 239097. Next, the monthly payment comes to 4,600, and we want to find how many monthly payments will be required. We set n as the unknown and input I equals 4.5 PV 213750, PMT negative 4600, FV0, PY 12, CY 12. We get n equals 52. Part D. We are told that the final payment is less than 4,600, and we want to find its amount. We use the same inputs but now with n equals 52 and calculate FV, which is 3893.2. The last payment is just the difference between 4,600 and 3893.2, which equals 706.8. Part E. We want to find how much money he will save by choosing this higher monthly payment plan. The total amount paid for the new plan is 51 payments of 4,600 plus the final payment of 706.8. Then subtract this total from the total in Part B, which gives a saving of 3790. Question 5. N represents the average number of cell phone cases the company sells each month, and it is modeled by the given equation. X is the selling price of each case. Part A. A man suggests that the price should be set at 16 per case. So we substitute x equals 16 into the equation to find n, and get n equals 4,000. The total income would then be the number sold 4,000 times the price 16, which gives 64,000. Part C. We need to write a function r of x that represents the total income. By using the same concept as before, income is price times quantity. So Rx equals x times 20,000 minus 1,000x. Simplifying, we get the expression. Part D. Now we have a fixed cost of 10,000 and a variable cost of 10 per case. We want to calculate the profit when x equals 16. That's total income 64,000 minus total cost, which is 10,000 plus 10 times 4,000. So the profit is 14,000. Part E. We are asked to show the given expression for profit. Using the same idea as before, profit equals income minus cost. The income is Rx, which we find earlier, and the cost is 10,000 plus 10 times the number of cases n. Substituting n from the original model and simplifying gives the required expression for profit. Part F. We need to find the derivative of px. Apply the power rule to each term. After differentiating, we substitute x equals 16 and see that the derivative is not 0. So x equals 16 does not give the maximum profit. Part G. Now the cost per case follows a new function c of n. We can first express c in terms of x using the relationship between n and x. To find the new profit function px, we use the same process as in Part E, but replace the 10 by this new cost function. After simplification, we get px equals negative 900x squared plus 26,000x. To find the selling price that maximizes profit, differentiate px, set it equal to 0, and solve. We get x equals 14.4.